We're going to continue talking about some different real-world applications of percents. Today, we're specifically going to be looking at markup and discounts. So markup is like the name suggests. You are marking up the price of something. So it's how much a retailer increases the price over what they paid for it. So it costs them a certain amount to make a product, but they need to earn money. So they are marking up the price. When a store sells an item for more than it pays for it is essentially what it's saying. And the amount of increase is called the markup. The selling price is the price after a markup is applied, right? The selling price is what they are selling it to you for. That's what you purchase it for. And the total cost is going to be the original price plus the markup. We're adding it. It's increasing the price. So let's look at just a general scenario with that. A pair of shoes that cost $40 was marked up by 25%. Find the markup and selling price. So even though this is kind of an easier percentage to work with, we're going to practice using this the proper way in a proportion. I'm going to find the markup first. We have our percent proportion out of 100. We are looking at 25%. The original pair of shoes was $40. What is that percentage? We're going to solve this proportion by multiplying 40 and 25, which equals 1,000. And then we are dividing that by 100 to get 10. So the markup is $10. Now, for the final, the selling price, so that is the markup, is $10. The selling price is going to be what they had to pay for it, or how much it cost them to make it, plus the markup, which means the store is going to sell it for $50. All right, discount and sale price. Well, discount is a markdown. It's the opposite. You are taking something off the price, or it's on sale. The amount by which the regular price of an item is reduced. The sale price is the price after the discount is applied, and this is the scenario where you're actually going to subtract the discount, right? It's taking money off that original price, so we're subtracting it instead of adding. So let's look at an example here. A couch that regularly sells for $450 was discounted by 30% off. Find the discount and sale price. So first, we're going to find the discount. There are a couple different ways that you could do this, but let's do it first by just finding what the discount is. So 30% off. If our percent proportion is set up, the percentage goes above the 100. 450 is the original amount. What is our discounted amount? So we're going to solve this proportion. 450 times 30 equals 13,500. We divide by 100 and we get $135 off. That's the discounted price. Our sale price is the original amount minus that discount, which is going to give us a sale price of $315. So this is how much it's discounted. That is what the price is going to be. And just like we did for tax and tip, we're going to look at some multi-step problems. So markup and tax, how it's going to work, just like with tax and tip. Not like tax and tip. This time when we're doing the multi-step problems, the order in which you calculate is very important. You are only taxed on what you are actually spending. So you are first You must first calculate the markup based on the original amount. Then you are calculating the tax on the sale price. It's not being taxed on the original amount, right? If something originally costs $100, but you're only paying $10 for it, you're not being taxed on 100, you're only being taxed on the 10, the new selling price, okay? For discount and tax, for markup, it's the price is going up. I just gave a discount example. For discount, right, same thing applies though. The order in which we calculate is important. You are first calculating the discount based on the original amount. Then you are calculating the tax on the discounted price, right? So for markup, I said that wrong, but for markup, you're adding to the price and you are paying tax on that new selling price. For discount, you're taking away from the price and you are paying tax on that discounted amount. So let's look at some problems. A mattress that regularly sells for $325 was discounted by 13% off. What would a customer pay for this item with a 7.25 tax added? We have to do the discount first. So that's what I'm gonna do first. Okay, setting up my proportion out of 100, 13% is what we're looking at for the discount. 325 is our total. As I'm calculating here, 325 times 13 is 4,225. We're dividing that by 100 to get 4,225. Which means this isn't what we're putting the tax on. That is the discounted amount, okay? We are taking that off of 325. So I'm gonna do 325 minus 4,225. And we are going to get 282.75 is our new selling price. Now I'm going to do tax on that amount, that discounted amount. So let's set up a proportion. The percentage for tax was 7.25%. We want to know what that is on our new price of $282.75. I'm going to solve this by multiplying $282.75 by 7.25. And I get a long decimal, 2,049.9375. Divide that by 100, and we get, I'm going to round, 20.50. So the tax amount that we're paying is $20.50. Tax is added to the price. So our final cost is going to be $282.75 plus $20.50, which is going to give us $303.25 for the final cost. Okay, so discount, we take that off, we tax on the discounted amount, add the tax to that, and get our total. Let's look at another scenario. A shirt that cost $12.50 was marked up by 22%. What would a customer pay for this item with a 6.5% sales tax added? So let's first find the markup. Okay, we've got our percent proportion. 22% is the markup. The original amount is $12.50. What is that markup going to be? Let's go ahead and solve. We are multiplying $12.50 times 22, which equals 275. Divide that by 100 and you get 275 for the markup. It is marked up. We are adding to the price. So I'm adding this to our original amount of $12.50. And that gives us $15.25. So that is our new price that we are using. $15.25 is what we are being taxed on. So let's set up our new proportion. Our tax rate is 6.5%. So we are figuring out our new amount, $15.25. What is 6.5% of that? So I'm multiplying $15.25 times $6.50 or 6.5, and we get 99.125. And I'm dividing this by 100 to get 0.99 when I round. That was our tax. Our tax is added to what we paid for. So we're doing our $15.25 plus 99 cents of tax, which gives us $16.24. All right, let's do one more scenario. A couch priced at $3,700 is on sale for 20% off. If the sales tax rate is 8.25%, what is the final price including tax? So I'm going to do this one other way. If the couch was $3,700 is 20% off, that means that the new price is 80% of the original. So I can do the same thing, setting up a proportion where I'm calculating our new price rather than calculating the discount. So if I want to do this, I can set up a proportion still out of 100, but this time I'm saying what's 80% of 100 because that's going to tell me what our new price is. So we've got our proportion that we know how to solve. I'm doing 3,700 times 80, which is 296,000. I am dividing by 100, which is $2,960. This isn't our discount. This is the new price because we said 80% of it is what the new price is going to be. So this is the number that we are going to use when we are calculating the sales tax. So our sales tax rate is 8.25%. I'm going to set up a proportion. Our total amount for the couch now is $29.60. We are figuring out what is the tax amount. So I'm going to multiply $29.60 times 8.25. And we get 24,420. Divide that by 100. And we get $244.20 for the tax. The larger the item, the more tax you're paying. Tax is added to what we are paying for the couch. So our total amount is going to be $29.60 plus $244.20, which is going to be $3,204.20.